Hi, welcome to this particular module. We talked about photo mask, right? Bright field photo mask and a dark field mask. So, these masks are master patterns which are transferred to wafers, and the types of photo mask are the Fe2O3 on soda lime glass. It can be a chrome mask, it can be bright field and dark field, as you know. These are some of the defects that are available that are generally observed in photo mask. One is a chrome spot. Now, why it is not important? Why it is very important? Particularly when you fabricate MOSFETs, then within this area you will have few thousands of devices that you will be killing because of the defects in that photo mask, which is your chrome spot. If you see the second image, you will see the chrome extension. Suppose I fabricate a heater, then this extension will create a different resistance compared to what I have calculated. Same thing, if there is a short, it is not acceptable because two lines will be short. If it is a metal, it is not at all acceptable. In other cases also it will create a lot of problem. If you have a spot, then this particular area again you are killing the chip. This crack will cause, or clear extension or a crack will also cause the change in the resistance if it is a resistor. The other properties are also affected when you have this kind of defect. Finally, a clear break is not allowed because you are if it is a conducting lines, then you are just breaking the connection. So, all these kind of defects are generally observed in a photo mask. So, before you use a mask, make sure that this kind of defects are not there. So, now let us understand and see the lithography videos, where you will be understanding two types of lithography. One is automated one and second is semi automated one. There is something called front to back lithography. Once we look at the video, we will be understanding what is front to back. Let me first play the first video.
Hello, my name is Bernhard from the ZUS Microtech development team. Today I'd like to present our new generation of production aligner, the MA200 Compact, which offers an advanced technology design, unmatched precision, and a high degree of flexibility. See for yourself how easy it is to operate. The chuck is stored in the bottom part of the aligner and is quick and easy to load. Equally easy to insert are the mask holder and the mask. Now I load the carrier. That's all there is to it, and the MA200 Compact is ready for operation. The processes of the MA200 Compact can be controlled via touch screen. For some processes, you can select between fully automatic and manual operation. A robot scans the wafers and determines their quantity, position, and size. And the processing begins. The MA200 Compact processes wafers and substrates up to 200 millimeters regardless of their material, size, shape, and thickness. The machine runs and adjusts fully automatically and is optimized for the processing of thick resists, such as with thick resist flip chip bumping, wafer level packaging, MEMS, nanotechnology, or telecommunication devices. The big advantage over steppers is the exposure of the entire wafer in one step. Thus, a throughput of more than 100 wafers per hour can be achieved with an overlay accuracy in the sub-micron range. Now, let's slow the process down and take a closer look. First, the wafer is pre-adjusted onto the pre-aligner in preparation for the ensuing alignment. A linear transport system loads the wafer onto the exposure chuck, which, together with the robot arm, guarantees the optimal and flexible handling of the substrate. No other mask aligner on the market offers a higher degree of alignment accuracy than the MA200 Compact. With the use of the recently developed and patent-pending Direct Align option from SUS, the mask is aligned directly to the wafer, guaranteeing an overlay accuracy of up to 0.5 microns at 3 sigma. The structures of the photo mask are conveyed via shadowcast. The patented wafer leveling system from SUS compensates for topographic variations and wedge errors, thus guaranteeing perfect alignment and exposure results. And the entire process is easy to monitor here on the touchscreen. Because of the MA200 Compact's newly designed microscope, during exposure, the mirror housing doesn't move forward. The microscopes only move sideways, thus reducing the vibrations of the alignment stage to a minimum, resulting in far greater accuracy. The optics of the MA200 Compact are optimized for thick resist processing. In thin resists, it achieves a resolution of 3 microns in proximity mode and a sub-micron resolution in contacts printing. A microscope for bottom side alignment is optionally available. It can process substrates with thicknesses of up to 4 millimeters. The MA200 Compact is a master when it comes to detail. Our idea while designing it was to create a device that is both user and maintenance friendly in order to further reduce your operational costs. The electronics and all important components are easily accessible, as well as being arranged in a clear and logical manner. Because of its compact size, it also saves valuable space in the clean room. The MA200 Compact is the ideal exposure system for application areas with high demands in terms of package densities and micromechanical structures. I can only recommend that you take a closer look at our new mask aligner in person, and would like to invite you to do so today. The MA200 Compact from SUS Microtech.
Okay, so you have seen the first video where it is about the automated kind of lithography system, where the robotic arm will pick up the wafer and will spin coat the wafer and the exposure will be done. While the second video that I am going to show you now is a semi-automated system, where the clean room user will show it to you how to expose the wafer from front side, as well as if I want to do front to back alignment, how to go for back side exposure. So, I will play that video.
This is the MA6. It's used to expose UV light to your substrate that has either photoresist on it. So before we run the machine, the first thing we got to do is make sure the light bulb is turned on or even not blown up. So we come out to the back, and you can see the lights turned on by the reflection here, or you can see the light glowing. So you know that the light bulb is on. But in addition to that, you want to find out how many hours are left on the light bulb. So you check the power supply. So you hold this button called DS, and it says 3226. That's how many hours the bulb is being used. So the bulb has a lifespan of 4,000 hours. So when it's over 3,500, you would notify staff and tell them to change it. So we're pretty close to that. Now that the bulb is okay to use, and there's nothing wrong with the bulb and the power supply, we want to log into the system. So before we log in, we check the logbook. And the logbook would say that the last person who used it was Monica on 221. And then you would check what notes she had or anything was wrong. So you can see there's nothing wrong. So we're ready to turn the machine on and log in. So the login computer is here. You have to log in to use the machine, otherwise it won't turn on. And the login has several functions. The first screen is the login, where you type in username and password. You can schedule to use a machine at different hours. Also, you should check this to make sure nobody else is using it. So today is the 24th, and it's 10 a.m. and there's nobody using it, so we're free to use it. Also, there's a history tab where we can see the last user. And you can see that Monica was the last user, and she was the last one to write in the logbook. So once we know the machine's ready and it's okay to use, we just log in. So once you've logged in, the machine will be able to power up. And what we do now is we turn the on switch on here. So we just turn it to the on switch. And you can see the machine starting up. And it's important to read the screen. It tells you a lot of information. So it says ready for start, press load button. So the load button's right here. So we press that. And now it says watch out, machine is starting up. You know when the machine is ready for load and started up when the information says ready for load. So before we run the machine, the one thing we can do is change the parameters. So you hit this button called edit parameter. And now you can adjust the parameters such as time and gap distance and type of exposure. So how do we edit the parameters or change the different parameters? We can use the X left and right. So we move this way. You can change the gap, change the type of contact, and then change the exposure type. So let's change the exposure time first. So it's at 5 seconds now. We can change it to 25 seconds. If you hold fast and up, you can change it faster. So it's a 25. Let's make it 26. Now we want to go slower, so we don't hit fast. So now we've adjusted the exposure time. Let's change the alignment gap. Let's make that 40. And then let's change the type of, we'll make it soft contact. And now new parameters have changed. There's different types of exposure types, from soft, vacuum, hard. You can look at the supplemental to get more information, but right now we'll set it as soft. So once your parameters are set, you can hit edit parameter. What we're going to do now is load the mask. So how do we load the mask? We press the button called change mask on the screen. So when you hit change mask, you're ready to load the mask. So we put it in here. So you would load your mask in here by lifting this clip here and putting it in. And when it's in nice, you hit this button called enter, and you can toggle the vacuum. So right now the vacuum is off. When you press enter, now the vacuum is on. And when you come back, you can see that it's vacuumed in and it's stuck pretty well. So now we're going to put this in here. So we carefully carry it. And we place it all the way in. And when it's in, we press change a mask. And that's how you load your mask. We're going to be doing a backside alignment now. So what this does is it aligns features on the back of your wafer to your mask. And how you do it is with a microscope from the bottom. So the first thing we do is we have to have a mask loaded, and then we turn the screen on, and we make sure this thing says backside alignment microscope is on, so it's on. But also we need to change this to backside alignment. So it can be either a topside alignment or it can be a backside alignment. So this is an illumination. So now the light is coming from the backside. So if you look in here, you can see the light hitting the features. So that's the microscope from here looking up and light hitting it. So we can look for those on the screen now. And pretty much what you do is this controls the microscopes on the back. So you can select one at a time and move around till you find your features. looks like we found alignment marks on the mask. So we need to adjust the focus. So you use this top straight left and right. So the left one adjusts the left, and the right one will adjust the right focus. You can also adjust the intensity. And you can also adjust the position. So if I want to move this one up and down, I would hit the right, and then I would move it up and down. If I want to move the left one, it's a similar thing. So when you find your mask and you think you're ready to do exposure and align it, you would grab this image. So you press grab image button right here. And when you press that, what it does, it takes a picture of the mask. And now we're ready to load the wafer. We press this button where it says load wafer. So it says pull slide and substrate onto chuck. And then we will just load our wafer on. And then when it's in, you press enter, and it'll bring it up. So now you can see you're in contact. This is the image overlay from the mask. And these features right here, see they're the bottom substrate of your wafer. So how do you move the wafer? We know that these buttons move the microscope. So how do we move the wafer? It's these buttons, right? It's these knobs right here. This is the Y. The X is on this side, and this is the tilt. So I'll give you an example. I can turn this, and you can see the background, these images moving. And then you can see this moving. So this is the Y position on the left side, and on the right side is the X knob. And you can adjust the tilt with this too. And you can adjust the focus, and you can adjust the intensity or light. So you would do that to find your alignment marks and then align them. So once you have aligned them, you're ready for exposure. And how do you expose? You press the first do alignment check, which will bring it up to touch. You want to make sure nothing moved. And then when it's in contact, you hit exposure. And then when you hit exposure, it's good to turn your back away from the light so it doesn't damage your eye. So we hit exposure, and then we just turn away. So after exposure, you need to unload your wafer. So what would you do is you would come to the screen, and it will say pull slide or unload exposed substrate. So you just pull it out, and then you press the enter button, and then the vacuum will be released. And you can take your wafer out. And then you would put it back in. So that's how you unload your wafer after exposure. What we're going to do now is topside alignment by using the microscope on the top to align to the wafer that's underneath through the glass. So to do topside alignment, we need to remove the backside microscope. So we press this button, that turns it off. Also, we need to put the illumination to the top side. And then we can load our wafer in. So again, you press load, and it says pull slide and load substrate onto chuck. And then you press enter when you did that. And the microscope will automatically come down because we have the BSA microscope light, button off. So now it's down, we turn the TV screen on. And what this is doing is taking putting the image from here onto the screen. So again, these buttons right here control the X and Y position of the microscope. So it looks like we found something here. So we can turn up. It's pretty. The power of illumination is pretty high intensity. So we can lower the power, and you can see that. So we got to find the mask alignment mark on this side. So there's different functions on this. This knob right here. So if you move it, this will control the light microscope, the X position of the right microscope. And the left side has the same button. So when I move the left knob, I can turn this way. When I move the right knob, I can turn it this way. We can adjust the tilt to make these match up by turning this knob right here. So they look like it's pretty matched up. So what would you do is you would do the same thing as similar to backside alignment. You would align your alignment marks on your wafer to these right here. So you can see that if I move this always, these knobs always control the substrate. So when I move this, you can see that this has been moved. So you can tell that's the actual substrate moving, not the mask. So you try to focus it, and you try to find your alignment marks and align them to the features. And then once you've aligned it, you do the same thing. You do alignment check, and then I'll bring the mask up, and then you would expose it. So you press expose, and then you do exposure again. So then you turn away so the UV light doesn't hit your eyes. So after you're done with exposure, you would unload your wafer. So it tells you pull slide or unload substrate. So you pull it out, and then you would take it out. When you finish your sample, you put this back in. Now if you're done, you want to move this back up and you don't want to bring it back down. This is where you press the BSA button. So by default, this will not come down. But also to bring this up, you press F1 and enter. And it will bring the microscope up. It's always good to leave it in this position with the microscope up and the BSA button on, because that way the microscope doesn't come on and up every time you're using it. So after that, we're ready to take out our mask. If we want to unload a mask, we press the change mask. It's pretty similar to loading it. It's a reverse process. You would press change mask. You would take your substrate out. You would hit the enter button to remove the vacuum. And then you would take your mask out. You would press the change mask button again. And it would confirm with enter that you know the mask is there. So now we're ready to turn the system off. So we want to make sure everything's in the standby position that you started the machine with. And then before you turn it off, you want to make sure you write in the logbook the different parameters. So the compressed air is about 4.9. The nitrogen is about 1.65. The vacuum is about 0.86. Negative 0.86. We used a 4-inch wafer with silicon, and we did 25-second exposure. Now we're ready to turn off. First thing we do is we turn off the switch here. And also the TV screen. And then we can log out here. And there's some messages like, did you reset the X, Y, and tilt position? And we did that. So we put OK.
Okay. So since you have seen both the videos, what we will be discussing in the next particular module is what is the importance of front to back alignment. Until now we were always understanding what is the front alignment, right, and how the front alignment will help, how can we create different interdigital electrodes if we want to create a sensing layer on it or something else. We are always exposing from the front side of the wafer. But if I want to create a diaphragm, so let me give you an example. If this is the wafer and this is the sensing area, this one, right, this is the sensing area. So I want to create a diaphragm exactly on the back side of this sensing area. That means I should align it on this side. How would I know it is perfectly aligned with the front side? that is what called front to back alignment, and to create a diaphragm exactly below this particular sensing area. This is where your front to back alignment will work. We will take an example in the next module. Till then you just go through these slides. Again let me reiterate that if you understand photolithography, you will be able to understand lot of techniques, lot of sensors and actuators fabricating techniques will become easier. The heart of micro engineering or a micro processing or manufacturing at a micro scale is always a photolithography system. So, if you have any questions, feel free to ask me in the forum. If you have any doubts, always feel free to ask. Do not hesitate, because this is not so easy to understand, okay, and at the same time it is extremely important. So, I do not want you to miss anything out of this particular module, but at the same time it is not that difficult also if you really focus, right. So, let us discuss the examples of front to back in the next module, and then we will actually move to the examples of using sensors and microfluidic systems for healthcare technologies, right. Till then you take care. I will see you in the next class.